Imagine you're in deep space, far away from any planet or any other source of gravity, and you have two boxes in front of you. So you're all just kind of floating together there in space. One of the boxes is a box that's full of styrofoam, a very light material, and the other box is full of bricks, a very heavy material. So how would you be able to tell which box is which? Imagine these boxes are covered so you can't see inside, and you have to use your senses to figure out which one's the box full of bricks and which is full of styrofoam. Well, take a minute, see if you could come up with a solution. What would you do? First of all, let me tell you what you can't do. You cannot just take these two boxes and put them on a scale to measure their weight. Because remember, we're in deep space and there's no gravity, which means on the scale, the box of styrofoam is going to read 0 because they're both just kind of floating there together. And the box of bricks, if you put it on that same scale, is also going to read 0 pounds. So, or 0 newtons or whatever unit of force you want to measure. So your scale is going to read 0 for both objects. You can't just weigh it. So what else can we do? So the solution to this problem actually comes down to Newton's second law of motion, which tells us that acceleration is equal to force divided by mass. That means the more force you push something with, the more it's going to accelerate, and the more mass an object has, the less it will accelerate. So how do we do the experiment to prove which is which? Just give them an equal push. And so the box of bricks has a lot more mass, right? And so you could think of it as this. You have a really, really big mass. And when the denominator of a fraction is very large, we expect the box of bricks to accelerate very, very slowly. It's going to be a mild acceleration. But when we do the same thing to the styrofoam, what's the difference? Well, the styrofoam has significantly less mass. So it has a really small mass in the denominator. And so when you push that object, it's going to have a very, very high acceleration. So although we can't weigh the two objects, we can give them a push, and the one that accelerates more is the one with less mass, and that's your styrofoam box.